Okay, so let's see how we can use the extended Euclidean algorithm in order to find the inverse. So we have A, and in Fm or F, which F we'll take Fm, and we want to find the inverse of this x of this A, which will be x, and we want to find it, which will be A to the minus 1. So in order for a element to have an inverse in a group, so if we are in Fm, so if A has an element, what is the property that should be fulfilled? So GCD of A and M should be 0 in order for A to have an inverse in this field. Let's call it Fm. Okay, so we have that the GCD will be 1 in order for A to have an inverse. Okay, and if x is an inverse of A, so A times x equals 1 in modular M, right? This states that x is the inverse of A, which is x is A to the minus 1. Okay, you can see it here. Now the extended Euclidean algorithm gives me ax times by equals GCD of A and B. So for two integers, the algorithm gives me the coefficients that if I have two integers A and B, the algorithm gives me the coefficients which fulfills the GCD of A and B. Now, in the case that GCD of A and B equals 1, we can say that AX plus BY equals 1 in modular M. Okay? Now, what we can do is we are looking for the GCD of A and M, right? M for we are in Fm. So the extended Euclidean algorithm will give me ax plus now our B is my, right, equals the GCD of A and M. Now the GCD, if A has an inverse, and the assumption is that it has an inverse and we want to find it, so it's 1. So equation is ax plus my equals 1 in modular M. But you can say that ax equals 1 minus my modular M. But m times some coefficient y, some integer y, again y is integer, modular m gives you 0. So what you get from this equation is that ax equals 1 mod m, or if you want minus 0, but we can just say this. So we get from the extended Euclidean algorithm this value. Therefore, x, this is the definition of an inverse, what we say. So x is a to the minus 1. So the x we get from the extended Euclidean algorithm of a and m is just the inverse. The value we get for x is the inverse. So again, let's do a summarization. And this is how we use the extended Euclidean algorithm to calculate the inverse. So we want to find an inverse of A, and we want to use the extended Euclidean algorithm. This is the definition of an inverse in a finite group of modular M. A times its inverse equals 1 modular M. And x is the inverse of A. Now we use the extended Euclidean algorithm. When we remember that this is the result of the extended Euclidean algorithm, it gives us that the GCD of A and B equals A times integer that we get from the extended Euclidean algorithm plus B times integer. Namely, the extended Euclidean algorithm gives me not just the GCD of the two numbers, but also which coefficients I should put for each number from the GCD in order to get the GCD value. Now what we will do is extend Euclidean algorithm of A and M. When we do that, and if we know that A has an inverse, so the GCD of A and M is 1, we get this thing, and extend Euclidean algorithm gives me Y and X. And it gives me them at a coefficient that I should put in order to get a GCD of A and M. Now, because A has an inverse and it's the field of Fm, so the GCD of AMN is 1. This is 1. So, and this one and this part, modular M, is just 0 because it's M when we are modular M, and we are multiplying it by an integer y, so it's just 0. So you can just get rid of it. And we are left with ax equals 1 modular m. So this is the definition for an inverse. So x is the inverse of a. And there is an example here. We want to find the inverse of 17 modular 26. We are running the extended Euclidean algorithm with 17 and 26. And we are doing the extended Euclidean algorithm. This is the Euclidean algorithm to find the GCD, and we can express, we get 1 because 17 has an inverse. So we now extend Euclidean algorithm will express this GCD, which is 1, as a linear combination of 17 and 26. And here it is, 1 equals this thing. Those are the coefficients for the parameters, and the GCD, the G is 1. Now, this part in modular 26 is 0, so we'll just get that the minus 3 is the inverse of 17 in modular 26. Okay, so this is it. This was about the extended Euclidean algorithm and how you can use it to find the inverse of a number in a finite field. Thank you very much, and thank you for Lemma. If there are any mistakes or correction, please tell me, and that's it.